In today's tutoring video series from Raritan Valley Community College, we'll be working on some problems from Chapter 1 about understanding units and conversions. The next question we're going to be looking at is going to be one involving water drops. So the problem states 1 cubic centimeter of a typical cumulus cloud contains 50 to 500 water drops, which have a typical radius of 10 micrometers. For that range, give the lower value and the higher value, respectively, for the following. How many cubic meters of water are in a cylindrical cumulus cloud of height 3 kilometers and radius 1 kilometer? How many 1 liter pop bottles would that water fill? And water has a density of 1,000 kilograms per meter cubed. How much mass does the water in the cloud have? So the first pieces of information that we need in order to begin solving this problem are formulas for the volume of a sphere, which is our water droplet, and a cylinder, which is our rain cloud. So we're going to start with the water droplet here, which is a sphere. And it has radius r, and the problem tells us that r is equal to 10 micrometers. And 10 micrometers is equal to 10 times 10 to the negative 6th meters. So the volume of a sphere is defined as 4/3 times pi r cubed. Now we know that r is 10 times 10 to the negative 6th meters, so we can calculate the volume of the sphere to be 4/3 pi times 10 to the negative 6th cubed. Ten times 10 to the negative 6 is going to be 10 times 10 to the negative 5. 10 times 10 to the negative 5th, negative 5 times 3 is going to be negative 15. So this simplifies to be 4/3 pi times 10 to the minus 15. And our units are going to be meters cubed because the radius of the sphere was measured in meters and it's a volume, so it's going to be cubed. Next, we need to find the volume of the cloud. And so the dimensions of the cloud are given as height equals 3 kilometers and radius equals 1 kilometer. 3 kilometers is equal to 3 times 10 to the 3rd meters. And 1 kilometer is equal to 1 times 10 to the 3rd meters. Now here is our cylindrical cloud with radius r and height h. And the volume of a cylinder is equal to pi r squared times h. Plugging in our known values, we can find the volume of the cloud to be equal to pi times 1 times 10 to the 3rd squared times 3 times 10 to the 3rd. So we can simplify the volume of the cylinder to be 3 pi times 10 to the 9th meters cubed. So now that we've determined the volume of the rain droplet, which we said is 4 pi over 3 times 10 to the minus 15 meters cubed, we'll call this V drop. There's 50 drops in 1 centimeter cubed. But the volume of our water droplet is in meters cubed. So we need to convert centimeters cubed into meters cubed. And we do this by setting up a conversion factor that converts centimeters into meters. And we have 100 centimeters in 1 meter. But since these are both cubed, we have to cube the conversion factor. This tells us that there is 50 times 10 to the 6th drops of water in 1 meter cubed. Since we previously calculated that the volume of the cloud is equal to 3 pi times 10 to the 9th meters cubed, and we know that there's 50 times 10 to the 6th drops per meter cubed, we can figure out how many drops there will be in the entire cloud. So we can do this by saying 50 times 10 to the 6th V drop over 1 meter cubed times 3 pi times 10 to the 9 meters cubed. And so we can see that the units of meters cubed will cancel each other out. By multiplying these numbers together, we can see that the result will be 150 pi times 10 to the 15 V drop per cloud. So in order to figure out the total volume of water in the cloud, we can multiply 150 pi times 10 to the 15 by the volume of water in one droplet. So we have 150 pi. So we have 150 pi times 10 to the 15 V drop per 1 cloud. And the volume of V drop we calculated as 4 pi over 3 times 10 to the minus 15 meters cubed. So if we plug that in, we have 150 pi times 10 to the 15 times 4 pi over 3 times 10 to the minus 15 meters cubed per cloud. So we can see here that the 10 to the 15 will cancel out with 10 to the minus 15, and 150 divided by 3 is 50. 50 times 4 is 200, so we're going to have 200 pi meters cubed per cloud. excuse me, 200 pi squared, because we have a pi here and a pi here. So we have 200 pi squared meters cubed per cloud. And this is the water content in the cloud. So that answers the first part of the question. How many cubic meters of water are in a cylindrical cumulus cloud of height 3 kilometers and radius 1 kilometer? So to review, we had to find the volume of the cloud, the volume of the droplet, the volume of 50 drops, and now we want to find that with 500 drops. So 50 drops has a volume of 200 pi squared. Well, 500 drops, so this is for 50 drops. 500 drops will have 200 pi squared times 10, because we have 10 times as many raindrops now. So we could say 2,000 pi squared. And that's going to be meters cubed per cloud. So in order to figure out how many 1 liter pop bottles this water would fill, we have to convert meters cubed into liters. So the conversion between liters and meters is 0.001 meters cubed is equal to 1 liter. Since we just found out that there was between 200 pi squared and 2,000 pi squared meters cubed of water in one cloud, we can convert both of those into liters. So we have 200 pi squared meters cubed per cloud. By setting up a conversion factor, we can convert 1 liter. We can convert to liters from meters cubed. So 200 pi squared, 200 divided by 0.001 is 200,000. Pi squared liters per cloud. Now, since we want an actual number of how many bottles that is, 200,000 times pi squared is 1.97 times 10 to the 6. Liters per cloud. And the last part tells us that D equals 1,000 kilograms per meter cubed. And right here, we know that the volume of water in the cloud is 200 pi squared meters cubed per cloud. And we can multiply that by our conversion factor, which has meters cubed on the bottom and kilograms on the top. And we have 1,000 kilograms per 1 meter cubed. So we're going to end up with 200,000 pi squared kilograms per cloud. And so this is actually the same numerical answer, but with different units as the previous question, and that's kilograms per cloud.